Alyssa Fensky is an extraordinary athlete that can deadlift more than 200 pounds. She's slower than a turtle going through peanut butter and is sponsored by I Hate Running Incorporated. Sadie Thompson is a speedy athlete who enjoys eating food on her days off from sleeping her life away. Sadie doesn't hit the weights, and she's certified to save your life. Katie Willander balls harder than Kobe and is 5'3" and in charge. She's a dirt bike extraordinaire and is en route to being famous via K. Willie Silly Lily We Hot You Not Productions. Sid Squidney Bartunik is famous for winning the state meet in slow walking. She's an expert at Dawson Drug and Gift, and her famous quote is "Keep calm, there's no quick fix."
Velocity is the change in distance divided by the change in time. The formula for velocity is delta x divided by delta t. To show how to calculate average velocity, I ran from one end of the gym to the other. I ran 25.6 meters in 4.91 seconds, and my average velocity was 5.24 meters per second.
As another demonstration of velocity, I putted a golf ball 2 meters on my living room floor. In order to find the average velocity of my golf ball, I had to take the displacement divided by time. I putted the golf ball 2 meters in 1.4 seconds, so I divide those two numbers and get 0.7 meters per second as my average velocity.
Acceleration is the change in velocity divided by the change in time. The formula for acceleration is delta v divided by delta t. To show how to calculate average acceleration, I threw a ball at Sadie's face. I threw the ball 3 meters and it took 0.94 seconds to hit Sadie, which gives me my average velocity of 3.2. I then multiplied that by 2 to find my final velocity. I then took my final velocity divided by 0.94 seconds to get my acceleration of 6.8 meters per second squared.
On your marks! Get set! Go!
As Katie said before, acceleration is the change in velocity divided by the change in time. Alyssa and I raced vehicles 30 meters in 3.6 seconds, which gives us our average velocity of 8.3 meters per second. I multiplied our average velocity by 2 to find our final velocity of 16.6 meters per second. I then took our final velocity divided by 3.6 seconds to get our acceleration of 4.6 meters per second squared.
The acceleration of gravity is 9.8 meters per second square. I dropped a kickball with 389 grams and a men's basketball with 566.9 grams. They both fell at the same rate of 9.8 meters per second squared.
To demonstrate gravity, I shot a free throw in the gym. When shooting, the ball is being forced upward by my arm. Gravity then brings the ball back to the ground through the hoop.
Hi, I'm here to demonstrate Newton's first law, which states that an object at rest will stay at rest and an object in motion will stay in motion. I will demonstrate this law via golf. As you can see, it's a lovely day for golf. So, if you look at my golf ball here on the tee, you can see that it's at rest. And it's going to stay at rest unless an outside force acts upon it. Now, when I hit the golf ball, it will stay in motion until gravity and air resistance eventually pull it back down to the earth. All right, we'll see how this goes. There you go. You couldn't see it, but the ball landed.
To show Newton's first law, I pushed myself from a resting position using force in my leg. When I hit Katie, who was at rest, my force moved her, therefore she pushed Sadie, who was at rest. Newton's second law is force equals mass times acceleration, or F equals ma. I pushed Katie 10 meters in 3.7 seconds and got a velocity of 2.7 meters per second. I multiplied that by 2 and got 5.4 meters per second. my final velocity. I then divided by 3.7 and got 1.46 meters per second squared. I then multiplied that by 63.5 kilograms, or Katie in the wheelchair's mass. And my final force was 92.71 newtons.
As Sydney said before, Newton's second law states that force is equal to mass times acceleration. To demonstrate this law, I deadlifted 40.82 kilograms in my school's weight room. Since we know that force is equal to mass times acceleration, to find the amount of force needed to lift the weight, I took 40.82 kilograms times the force of gravity, which is 9.8 meters per second squared. This gives me a total of 400 newtons of force.
Newton's third law states for every action there's an equal or opposite reaction. To demonstrate this law, I sat on a chair and my force pushed down on the chair while the chair pushed up an equal amount of force. What a nice friend.
Newton's third law states that every action has an equal but opposite reaction. This is demonstrated when Alyssa tackles me and her force pulls me down.
Oh, wait. Oh, crap. Oh, crap. Oh, my gosh, I'm going to hit it. Looks like the little blue car is going to need a paint job.